Is Aqua Security the right CNAPP for your cloud-native stack? In this review, we break down what Aqua does, how it works, who it is best for, how it compares to peers, and what to expect on pricing and deployment. Start with the core problem. Modern applications run on containers, Kubernetes, and serverless functions. These environments are dynamic and ephemeral. Traditional perimeter tools cannot see inside containers, cannot enforce in the Kubernetes control plane, and cannot follow the software supply chain from code to runtime. That is why CNAPP exists. A CNAPP unifies posture management, workload protection, identity analysis, and supply chain controls into one program. Aqua Security began in 2015, focused on containers, and quickly expanded to Kubernetes and serverless. Today, Aqua provides a CNAPP that covers CSPM for cloud accounts, KSPM for Kubernetes posture, CWPP for workload runtime defense, CIEM for cloud identity risk, and software supply chain security from development to registries to production clusters. The company is known for deep technical coverage of Kubernetes and for its open-source tools that many teams already use. Does Aqua use AI? Aqua blends deterministic rules, policy as code, and behavioral analytics. The platform builds baselines for processes, file access, and network activity in containers, then alerts or blocks when behavior drifts. Machine learning helps with anomaly scoring and noise reduction, but core prevention relies on transparent, explainable policies. This approach reduces black box surprises while still benefiting from adaptive detection. Let us walk through the main modules. In development, Aqua scans source repos, Docker files, Helm charts, Terraform, and container images for CVEs, secrets, and hardening issues. It generates SBOMs and SPDX or CycloneDX, tracks package provenance, and enforces build pipelines by failing a job if risk exceeds policy thresholds. Integrations include GitHub Actions, GitLab CI, Jenkins, Azure DevOps, and major artifact registries such as Amazon ECR, Azure Container Registry, and Google Artifact Registry. In admission control, Aqua evaluates Kubernetes deployments before they start. Policies can block images with critical vulnerabilities, disallow privileged pods, or mandate signed images and runtime class constraints. This shift-left gate prevents risky workloads from ever running. For runtime protection, Aqua deploys lightweight agents or eBPF-based sensors on Kubernetes nodes as daemon sets. The sensors observe system calls, file integrity, and network connections. Aqua builds a profile of allowed behavior per image or service, then detects drift such as unexpected shells, crypto miners, or data exfiltration patterns. Drift prevention can block binaries not present at build time. Combined with Kubernetes native controls like pod security levels and network policies, Aqua provides defense in depth. Serverless functions are scanned for vulnerabilities, hard-coded secrets, and excessive permissions. For VMs or legacy workloads, Aqua provides malware scanning and runtime controls, though its sweet spot remains cloud-native platforms. Posture management consolidates misconfigurations across AWS, Azure, and Google Cloud. Aqua checks IAM roles, storage exposure, network segmentation, encryption, logging, and key management against frameworks like CIS benchmarks, NIST, and PCI. In Kubernetes, KSPM audits API server flags, etcd configuration, RBAC, and namespace-level isolation. Findings roll up into risk scores with remediation guidance and can be ticketed automatically into Jira or ServiceNow. Visualization through a risk explorer helps teams prioritize attack paths that combine identity, misconfiguration, and exploitable workloads. Supply chain security is a notable strength. Aqua signs artifacts, verifies signatures at deploy time, and traces components through SBOMs. Policies can require provenance attestations using frameworks like SLSA and Intoto. This reduces the blast radius of dependency compromises. Open source is a major advantage for adoption. Trivy is one of the most popular scanners for vulnerabilities, misconfigurations, and secrets across containers, Kubernetes, file systems, and IAC. kube-bench evaluates clusters against CIS Kubernetes benchmarks. kube-hunter simulates adversary reconnaissance. Trivy operator brings continuous posture checks into the cluster. Teams that standardize on these tools can later connect them to Aqua's enterprise platform for central policy, reporting, and SLA tracking. Integrations are broad. Aqua exports findings to SIEM and SOAR platforms like Splunk, Elastic, Datadog, and Microsoft Sentinel. It supports admission via Kubernetes webhooks, policy as code via Rego and YAML, and secret management with Vault and Cloud KMS. For container runtimes, Aqua supports Containerd and Docker. It works across EKS, AKS, GKE, OpenShift, and self-managed Kubernetes. Strengths include deep runtime enforcement for containers, robust CI and registry controls, a mature admission controller, broad cloud posture coverage, and an open-source ecosystem that lowers barriers to entry. The platform's risk context ties cloud, identity, workload, and pipeline data together, which helps reduce alert fatigue and direct effort to high-impact fixes. Limitations to plan for. Tuning is required to minimize noise during the first weeks of deployment. Teams should stage enforcement by moving from monitor to block modes gradually. There is agent overhead for runtime telemetry, although eBPF helps reduce it. Costs can rise at very large scale if every namespace and workload is fully instrumented. The richness of features means new users benefit from enablement and reference architectures to shorten time to value. How does Aqua compare to others? Wiz and Orca emphasize agentless posture and attack path analysis with very fast time to value. Aqua goes deeper in runtime prevention and supply chain gates, which is valuable for regulated or high-risk production environments that must stop attacks, not just alert.
Prisma Cloud offers broad platform coverage under one vendor, with tight firewall and network integrations. Sysdig is known for eBPF runtime depth and Falco rules heritage. Snyk is strong in developer-first SCA and container scanning with ecosystem breadth. The right choice depends on your prioritization of prevention versus detection, agentless speed versus deep runtime, and how tightly you need to control the CI pipeline. Pricing is subscription-based and varies by deployment model and scope. Common metrics include number of protected nodes or hosts, images or artifacts scanned, and cloud accounts. SaaS simplifies operations while self-hosted can meet strict data residency requirements. Expect enterprise support that includes onboarding, best practices, and integrations. Many customers begin with open source and a focused paid rollout on critical clusters, then expand coverage once policies are tuned. Who benefits most from Aqua? Teams running Kubernetes at scale that need enforceable runtime controls, organizations with strong compliance requirements that mandate preventative gates, and DevSecOps programs investing in supply chain integrity and SBOM-driven governance. If your priority is rapid cloud posture visibility without deploying sensors, agentless first platforms may be faster to start. But Aqua's runtime guardrails will add value as you mature. Final guidance. Pilot Aqua in a single cluster with a realistic workload. Start with registry scanning, admission control, and read-only runtime sensors. Integrate Trivy into your builds. Measure outcomes such as blocked risky deployments, time to remediate critical CVEs, and reduction of unknown processes in production. Expand enforcement once baselines are stable. Compare total cost and operational effort against your shortlist that likely includes Prisma Cloud, Wiz, Sysdig, Orca, and Snyk. This deliberate approach will show whether Aqua's combination of open source, runtime depth, and supply chain governance aligns with your risk model and culture.